9 out of 10 drivers accept dealership repair quotes as absolute gospel. They hand over their credit cards for basic maintenance disguised as complex engineering. That ends today. The automotive industry banks on your hesitation, selling you overpriced fluids, unnecessary hardware, and phantom labor hours. There is a hidden catalog of brilliant mechanical bypasses that bypass the service bay entirely. We are exposing 15 genius car hacks that prevent breakdowns and keep your cash. Let us begin. Hack 15. The air conditioning relay swap. You're driving on a sweltering summer afternoon and your vents suddenly start blowing warm air. The sudden loss of air conditioning sends most drivers straight to the repair shop in a panic. Modern air conditioning compressors are engaged by a magnetic clutch, which is controlled by a simple electrical relay. Due to the constant cycling on and off, the internal metal contacts of this relay become pitted and burnt over time. The relay stops sending power to the compressor, making the entire system appear dead. You do not need a mechanic to diagnose this. Open your underhood fuse box and locate the air conditioning relay using the diagram on the lid. Locate your horn relay, which is almost always the exact same part number and size. Swap the two relays. If your air conditioning instantly blows cold air, you have found the problem. You can buy a new relay at the auto parts store for $5 and install it yourself. We are shifting from the cabin cooling system to the engine diagnostics next. The upcoming trick exposes a mechanical illusion that costs people thousands. Hack 14, the cigar smoke vacuum leak test. A rough engine idle is one of the most frustrating symptoms a car can develop. You stop at a red light and the engine shudders. The RPM needle bounces and the check engine light illuminates. Dealerships will throw expensive parts at this problem all day. They will charge you for new mass airflow sensors, spark plugs, and expensive throttle body cleanings. The actual culprit is usually unmetered air entering the engine through a cracked $20 rubber vacuum hose. Finding a microscopic crack in a maze of black rubber hoses is like looking for a needle in a haystack. Professional shops use a machine that pumps pressurized mineral oil smoke into the intake to find the leak. You can replicate this exact diagnostic test in your driveway using a cheap cigar. With the engine turned off, remove the main vacuum hose connected to your brake booster. Light the cigar. Take a deep draw and blow the thick smoke directly into the brake booster hose. The smoke will travel through the entire intake manifold and pressurize the vacuum system. Shine a bright flashlight into the dark corners of the engine bay. You will see a thin, distinct plume of smoke exiting the exact location of the cracked hose or failing intake gasket. You wrap the damaged hose with electrical tape for a temporary fix and order the cheap replacement part. Finding an air leak with smoke is a brilliant diagnostic shortcut. But wait until you see how we diagnose belt noises. Our next method uses a common household liquid to silence the engine bay. Hack 13, the serpentine belt. Water diagnostic. You start your car in the morning and a loud, high-pitched squeal echoes from the engine bay. The noise increases as you press the gas pedal. You need to isolate the exact cause of the noise before you replace a single part. Take a standard plastic spray bottle and fill it with plain tap water. While the engine is running and the belt is squealing, stand clear of the moving parts and spray a light mist of water directly onto the ribbed side of the serpentine belt. If the squeal instantly stops for a few seconds and then returns as the water dries, you have isolated the problem to a worn or hardened rubber belt. The water acts as a temporary lubricant. However, if you spray the belt and the noise gets louder or does not change at all, the belt is fine. The noise is coming from a failing metal bearing inside one of the steel pulleys. You just narrowed down a $300 repair to a $20 specific part. We are moving down to the steering rack. Now you will want to stick around for this because a noisy steering wheel is the biggest moneymaker for suspension shops. Hack 12, the syringe power steering flush. Every time you turn your steering wheel at low speeds, the car emits a loud groaning whine that sounds like a dying whale. The steering feels heavy and sluggish. Power steering fluid is a hydraulic oil subjected to extreme pressure and heat. Over years of driving, the fluid breaks down, loses its lubricating properties, and becomes contaminated with microscopic metal shavings. The thick, dark fluid causes the internal veins of the pump to struggle, creating that loud groaning noise. You do not need to drain the entire system from the bottom of the car, which requires specialized tools and makes a massive mess. Purchase a large plastic extraction syringe or a simple turkey baster. Open the power steering fluid reservoir and suck out all the dark, contaminated fluid. Refill the reservoir to the maximum, line it with fresh factory-approved fluid. Drive the car for 2 days, allowing the new fluid to mix with the old fluid trapped in the steering rack. Repeat this extraction and refill process 3 times over the course of a week. You will cycle out the degraded fluid entirely, the groan will vanish, and you just saved the life of your expensive steering pump. Fluid dynamics can solve mechanical problems, but sometimes you need targeted chemical intervention. The next trick fixes a frustrating interior issue that plagues aging vehicles. Hack 11, the silicone window track glide. You press the button to lower your driver's side window. The glass travels down normally, but when you try to roll it back up, it struggles. The motor sounds like it is dying. The glass tilts to one side and it barely makes it to the top. The electric motor and the metal regulator are usually in perfect condition. The problem lies in the vertical rubber tracks that guide the glass. As a car ages, sun exposure and dirt cause the soft rubber window channels to dry out and harden. The dry rubber creates massive physical friction against the glass, overwhelming the small electric motor. Roll the window all the way down. Take a can of pure silicone spray lubricant containing the small red straw attachment. Spray a generous amount of the silicone fluid directly into the vertical rubber channels on both sides of the window frame. Roll the window up and down several times to distribute the lubricant. The pure silicone softens the dry rubber and creates a slick, friction-free surface. Your window will immediately glide up and down with rapid factory-like speed. Silicone is safe for rubber components, but applying the wrong chemical to the engine can cause catastrophic failure. Our next hack addresses a massive mistake people make when performing basic tune-ups. It is crucial knowledge for anyone turning a wrench. Hack 10, the spark plug anti-seize. Trap drivers decide to save money by changing their own spark plugs. They watch a few old tutorial videos and head to the part store. They buy the plugs in a tube of silver anti-seize paste. The logic seems sound. Smearing a thick layer of anti-seize on the threads will prevent the spark plug from getting stuck in the aluminum engine block in the future. This habit is a leftover from the 1980s, and applying it today will destroy your cylinder head. The paste acts as a powerful lubricant. When you use a torque wrench to tighten the plug to the factory specification, the lubricated threads slide too easily. You end up over-tightening the spark plug by up to 30% before the wrench clicks. This massive over-torquing stretches the metal threads, cracks the ceramic insulator, and strips the delicate aluminum threads right out of the engine block. A simple maintenance task transforms into a massive machine shop repair. Install modern spark plugs entirely dry. Trust the factory metal plating to do its job. We are leaving the top of the engine and moving to the transmission. If you experience harsh, violent shifting, you must understand the following procedure before agreeing to a rebuild. Hack 9, the transmission solenoid screen. Purge. Your automatic transmission shifts perfectly through the lower gears, but when it attempts to shift into overdrive, the car jerks. The check engine light comes on, accompanied by a harsh shifting code. Before you accept a massive rebuild quote, you must understand how an automatic transmission actually shifts. The gear changes are controlled by electronic shift solenoids bolted to the outside of the transmission body, or the internal valve body. These solenoids act as hydraulic gates opening and closing to direct pressurized fluid to protect the delicate internal valves. These solenoids are fitted with a microscopic metal mesh screen. Over time, normal friction material from the transmission clutches sheds into the fluid and completely clogs these tiny mesh screens. The solenoid cannot push the fluid through the stock clog screen, causing the transmission to slam into gear. You can drain the fluid, drop the pan, and unbolt the shift solenoids yourself. Take a can of brake parts cleaner and blast the microscopic metal screens until they are spotless. Reinstall the clean solenoids and fill the transmission with fresh fluid. The hydraulic pressure is restored and the harsh shifting disappears entirely. Cleaning a mechanical screen is straightforward, but finding an invisible electrical leak requires strategy. The next trick teaches you how to hunt down the phantom energy, draining your battery while you sleep. Hack 8, the multimeter parasitic draw hunt. You install a brand new battery in your car. 2 days later, you walk out to the driveway, turn the key, and the engine refuses to crank. You jumpstart the car, the alternator charges the battery, but the same thing happens the next morning. Mechanics will blame the new battery or sell you a new alternator. The real problem is a parasitic draw. A computer module, a stuck relay, or an aftermarket alarm system is failing to go to sleep when you turn off the key, silently draining the battery overnight. You can find the exact module causing the drain using a $20 digital multimeter. Disconnect the negative battery cable. Set your multimeter to read direct current amperage. Touch the black multimeter probe to the negative battery post, and touch the red probe to the disconnected negative cable. You have placed the meter in series, forcing all the electrical current to flow through the screen. A sleeping car should pull less than 50 milliamps. If your screen reads 300 milliamps or higher, you have a massive parasitic draw. Leave the meter connected and resting on the windshield where you can see it. Open your fuse box and begin pulling out the fuses one by one. Keep your eye on the multimeter screen. When you pull a specific fuse and the amperage reading instantly drops back down to a normal sleeping range, you have found the circuit. Look at the fuse diagram to see what that fuse controls. You just isolated a complex electrical drain to a single component without paying a diagnostic fee. Electrical diagnostics are satisfying, but dealing with brake computers can be intimidating. The next hack simplifies a terrifying dashboard warning light down to a basic cleaning task. Hack 7, the ABS sensor iron dust wipe. You are driving on the highway and your dashboard suddenly lights up like a Christmas tree. The anti-lock braking system, warning light, the traction control light, and the stability control light all illuminate simultaneously. You lose your advanced braking features. A trip to the dealership yields a scanning report pointing to a failed ABS control module or a ruined wheel hub assembly carrying an estimate over $1,000. The advanced braking systems in your car rely entirely on wheel speed sensors located behind each brake rotor. These sensors read a magnetic toothed ring on the spinning axle. To read the metal teeth, the tip of the sensor itself is highly magnetic. As your brake pads wear down, they release millions of microscopic iron and steel particles into the air. These metallic particles are magnetically attracted directly to the tip of the wheel speed sensor. Over a few years, the sensor tip grows a thick beard of magnetic metallic dust. This metal dust creates a barrier, blinding the sensor so it can no longer read the spinning axle. The computer assumes the wheel has fallen off and disables the entire system. Unbolt the single 10mm bolt holding the sensor into the steering knuckle. Pull the sensor out and wipe the thick metallic sludge off the magnetic tip with a clean rag. Reinstall the clean sensor. The computer can read the wheel speed again, and the dashboard warning lights turn off automatically. A clean sensor fixes the brakes, but a repaired wire dictates how the engine runs. The upcoming hack exposes a fundamental mistake people make when repairing damaged engine wiring. It involves understanding atmospheric science. Hack 6, the oxygen sensor crimp rule. Your check engine light points to a failed oxygen sensor. You slide under the car to investigate and find that road debris has ripped the wires cleanly out of the sensor harness. The instinct of any handy driver is to grab a soldering iron, melt some lead solder over the broken wires, wrap them in electrical tape, and call it a day. When you start the car, the engine runs terribly, and the oxygen sensor code returns immediately. You did not fix the sensor, you suffocated it. An oxygen sensor does not just measure the exhaust gases inside the pipe. It must constantly compare those exhaust gases to the clean ambient air outside the vehicle to calculate a proper ratio. Automotive engineers did not drill a hole in the sensor body for this ambient air because water and mud would destroy it. Instead, they designed the sensor to breathe atmospheric oxygen straight through the microscopic gaps between the copper wire strands traveling inside the plastic wire insulation. When you use a hot iron to melt solid lead solder across the broken wires, you create a solid metal block. You physically plug the microscopic air gaps. The sensor can no longer breathe ambient air through the wire harness, rendering it totally blind. If you must repair an oxygen sensor wire, you must use mechanical crimp connectors. Crimping the wires together maintains the microscopic gaps between the copper strands, allowing the sensor to breathe and function perfectly. Airflow is critical for sensors, but fluid flow dictates the climate inside your cabin. If you face freezing morning commutes with a broken heating system, the next method is for you. Hack 5, the heater core reverse. Flush winter arrives, the temperature drops, and you turn the climate control dial to maximum heat. Instead of warm air, the vents blow freezing cold air into the cabin. The engine temperature gauge reads normal, meaning the engine is hot. A repair shop will diagnose a clogged heater core. The heater core is a tiny radiator buried deep inside the dashboard. To replace it, a mechanic must remove the entire dashboard shell and the central console. The labor bill alone will exceed $1,000. The heater core is usually not broken. It is simply obstructed by a thick mineral scale and neglected coolant sludge blocking the tiny aluminum tubes. You can clear this blockage from the engine bay without ever touching the dashboard. Locate the two black rubber heater hoses connecting the engine block to the firewall. Disconnect both hoses. Take a standard garden hose and press the nozzle firmly against the outlet hose of the heater core, the one that normally returns fluid to the engine. Turn the water pressure on high. You are forcing clean water backward through the heater core, reversing the normal direction of flow. The reverse pressure dislodges the heavy scale and sludge trapped against the internal tubes. A horrific slurry of brown rust will blast out of the inlet hose. Continue flushing until the water runs crystal clear. Reconnect the hoses and bleed the cooling system. The hot engine coolant can flow freely through the dashboard again, restoring intense heat to your cabin. We are shifting from the heating system to the hydraulic braking components. The next hack reveals a specific brake failure that creates the illusion of a seized metal caliper. Pay close attention to the diagnostic test. Hack 4, the flex hose. Brake caliper illusion. You notice a strong smell of burning brakes after a short drive. You check the wheels and find the front passenger wheel is radiating intense heat. The brake caliper is locked tight against the rotor. You assume the metal piston inside the caliper has rusted and seized. You purchase a new caliper, bleed the brakes, and go for a test drive. The new caliper locks up just like the old one. You wasted your money because you misdiagnosed the hydraulic flow. You can confirm this in the driveway. When the brake is locked tight, take a wrench and crack open the bleeder screw on the back of the caliper. If a spurt of pressurized fluid shoots out and the brake caliper instantly releases its grip, the metal caliper is fine. The fluid was trapped by a collapsed rubber flex hose. Replace the $20 hose to solve the problem permanently. Hydraulic locks are frustrating, but suspension noises are maddening. The upcoming trick quiets clunking suspension parts without removing a single bolt. Hack 3, The strut mount needle injection. You drive over a speed bump or a pothole and a loud, hollow clunk echoes from the front suspension. The steering also feels slightly bound up when turning at low speeds. A mechanic will put the car on a lift, shake the front wheels, and tell you the entire McPherson strut assembly is worn out. They will quote you for new struts, new coil springs, and an alignment. The clunking noise is often generated by the strut bearing located at the very top of the suspension assembly, right beneath the hood. This bearing allows the entire suspension strut to pivot smoothly when you turn the steering wheel. Over the years, the factory grease inside this bearing dries up and washes away. The dry metal balls grind against the plastic housing, creating the clunking sound and the binding sensation. You do not need to remove the heavy suspension strut to fix this. Open the hood and locate the circular rubber top mount of the suspension tower. Purchase a specialized grease needle attachment for a standard grease gun. Slide the sharp needle directly under the rubber dust seal of the strut bearing. Slowly pump a high-quality marine-grade grease directly into the dry bearing housing. Rotate the steering wheel lock to lock a few times to work the fresh grease into the ball bearings. The heavy grease eliminates the metal-on plastic friction, instantly silencing the clunk and restoring a smooth steering feel. Lubrication fixes mechanical binding. But what happens when alternating current invades your direct current vehicle? The next hack exposes an electrical ghost that mimics failing computers and dead batteries. Hack 2, the alternator diode ripple. Test. Your vehicle begins acting as if it is haunted. The dashboard lights flicker rapidly. The radio turns on and off randomly and the transmission shifts erratically. You take the car to a parts store and they hook up a basic battery tester. The tester confirms the battery is good and the alternator is outputting 14 volts. The parts store employee shrugs. A dealership will start charging you thousands to replace electronic control modules, guessing at the problem. Modern car computers cannot handle alternating current. The chaotic electrical waves scramble the digital signals, causing the flickering lights and the erratic shifting. You must test for this specific failure. Set your digital multimeter to read alternating current voltage. Touch the probes to the battery terminals while the engine is idling. A healthy alternator will show less than 50 volts of alternating current. If the screen displays anything higher, the internal diodes have failed. You need a new alternator, not new computers. We have arrived at the final mechanical bypass. This is the ultimate roadside survival trick. It has saved countless drivers from expensive tow truck bills and desolate parking lots. Hack 1, the starter motor hammer, tap. You finish grocery shopping, sit in your car, and turn the ignition key. Instead of the engine roaring to life, you hear a single solid click. The dashboard lights remain bright, proving the battery has full power, but the starter motor refuses to spin the engine. You are stranded. A tow truck will cost $200, and the shop will charge $30 more to install a new starter motor on Monday morning. You can bypass the tow truck using brute physical force. An automotive starter motor contains internal carbon brushes that press against a spinning copper commutator to transfer electrical power. Over thousands of starts, these carbon brushes wear down, and the heavy copper contacts become pitted and scarred. The internal components land on a dead spot, breaking the electrical connection. The magnetic solenoid clicks, but the motor receives no power. You need to physically jar the internal components to re-establish the electrical connection. Locate the cylindrical starter motor bolted to the side of the engine block near the transmission bell housing. Take a heavy metal object such as a long tire iron, a wrench, or a hammer. While a friend holds the ignition key in the start position, reach down and strike the metal casing of the starter motor firmly a few times. Do not smash it. Just deliver a few solid, vibrating taps. The physical shock wave travels through the metal casing, jolting the internal carbon brushes slightly forward off the dead spot. The electrical connection is instantly restored, and the starter will crank the engine to life. This bypass will only work a few times before the starter fails permanently, but it provides the exact mechanical lifeline you need to drive the car safely home or directly to the parts store.